Hi, we meet again. Now I only have to have a open discussion about the AHUs. We learned that to control the air we need heat exchangers, and the heat exchangers are either DX or the temperature is controlled by actuators that allow more or less cooling or heating agent to pass by. What you'll see here, this is an actuator and a valve. So the actuator will act onto the valve, allowing more or less fluid to pass by. The fluid I'm talking about could be a cooling agent, like you see the blue color, or can be a heating agent, hot glycol water, or steam. When you reach the desired temperature, then you can stop the heating or cooling agent, and this is a fault condition in which the shaft of the valve it's probably corroded and it's seized. Is not the spring doesn't push the shaft upwards to follow the actuator. So this is a fault condition. Even if the actuator want to close the valve, the shaft is seized because probably it's corroded, and you'll have a flow. Now, if the pump doesn't run in a system, we all know there won't be any cooling or heating agent flow to the system, and there'll be a good idea the PLC to run sometime like this to clean the shaft. Now, this is a three-way valve. It have the capability to divert the flow. So, as you'll see, the valve opens and allows the heating agent to pass by. And to one point, when you try to divert it, it can't, because again the valve shaft it is seized and it's not moving. In this case, you will provide a heating agent to the heat exchanger all the time. You'll see this again, so you'll see how important it is for the valve to work. Now you divert the heating agent because you don't need flow, and what happened just now, you will have a heating agent passing by to the heat exchanger, and part of it is diverted because this valve is not 0 and 1, it is from 0 to 100%. So now the capacity is 100%. You will have all the heating agent passing by to the heat exchanger, and what you'll see now is diverted again. So I did this little game so you'll understand. This valve is 0 to 100%, so you can control the amount of heating agent that passing by to the heat exchanger. This is used for temperature control. So if you need more heat, you will open the valve 100%. Again, this is a fault. You see the valve has got the shaft seized, and the entire quantity of, a big flow of heating agent passing by to hit the heat exchanger actually is seized at 100%. A good idea, as I said, is that the programmable logic controller, the BMS, will turn off and on the valve 100% to clean the shaft, and then the faults will not be very likely to happen. This shaft will clean itself because the actuator will push him down to the limit and then will release it. If the boiler or the chiller doesn't work, you wouldn't expect to have cooling or heating even if the valve it is 100% open. You have to heat the heating agent before you will hit the heat exchanger. So sometimes doesn't matter if you open 100%, the actuator and the valve will allow the heating agent to flow. If the boiler is not heating the heating agent, then you won't hit the heat exchanger. Please stay with me, learn more about what happens when the coil is icing up, when you run the heat exchanger by using glycol below 0 point. As you will see here, you have a negative pressure in between the fan and the heat exchanger, and the heat exchanger is iced up. And now the right hand side heat exchanger is icing up. You have a high static in between the fan and the main cooling coil, and no airflow after the cooling coil. Also here you can see an incorrect system. It's a little bit hard to explain. I will do another video specific for this one to explain. This is an incorrect design. Some people thought if they will use a desiccator to run very low moisture into the air, they will avoid the ice and up phenomena on heat exchanger that run on minus 15 degrees glycol, minus 6 degrees glycol, sorry. Here we did some modification to the system. We convert the heat exchanger in a cooling heat exchanger, and we raise the glycol temperature a little bit, hoping to avoid the ice and up phenomena. But this is just a project. We didn't do this project yet. We work on it. We have to do some calculation. Here again, you will see that when you use glycol below 0 degrees, this is a minus 15 degrees system, the heat exchanger is icing up, and we are using steam to defrost the heat exchanger, and then we will use it again. This is the way we are wiring some of the units, and here I want to explain to you how the absolute humidity, relative humidity, and temperature are acting. This heat exchanger runs above the dew point. You see the absolute humidity is not modified, even if the relative humidity go high and the temperature go low. To remove moisture from the air, we have to run this heat exchanger cooler. If you look to the blue line where it's written absolute humidity, you will see it now. It drops because we run the coil cooler below the dew point, and then the air will leave droplets of water onto the heat exchanger, and the water will go down on a drip tray and will be eliminated via the drain pipe. So a couple of things you have to understand about air handling unit. And also here you will see, if you increase the temperature, again you will not modify the absolute humidity, but the temperature will be increased and the relative humidity reading will be lower, so you will drop. Don't be confused with relative humidity. So I'll explain this in another video. Here I want you to see how room heat load can be affected by incorrect door usage, and again I will do this in another video because it is a little bit to talk about. Thank you very much, and I'll see you on the next video.